Hi everyone, Dan McJunkin here with Residential Estimating Service, your home for lumber takeoffs and whole house estimates as well. Thank you for taking the time to stop by. Today we're going to be talking about architectural plans and engineering plans. You know, a lot of owner builders and some young builders don't really understand that an architectural set of plans may not have the engineering data in order to meet all codes, and for that reasons most professional builders will go ahead and hire a structural engineer for both the foundation as well as the frame on the home. So this is something that's near and dear to my heart, and I just wanted to do this video because I'd like to set the record straight on a few things as much as I can, remembering that I'm an estimator, not an engineer, and I always refer to the experts whenever I'm given the opportunity. Take a look at this with me, and this is going to be a program that I use called PlanSwift, and PlanSwift is a great tool for me when I estimate, and I can do a lot of things, including some of the engineering issues that are here. But what I want you to see here is a very well drawn set of plans. It is not a National Architect plan, as far as I can tell. It's a custom drawn set of plans, and it really is a stellar set of plans. But as well drawn as this plan is, it's not engineered unto itself. We have a separate set of plans that is created by the structural engineer. Now, the engineering mirrors, in many ways, the architectural plans. In other words, the idea of the plans. I'll show you what I'm talking about. When we look at the front of the home, obviously we can tell what from the design where siding is going to go and where certain vertical siding is going to go. That's called raised batten and board, or RB&B. And then we can see where like the columns are going to be, and there's going to be some shutters. I consider this to be a graphical specification. In other words, we could almost write this on a piece of paper and describe what we're seeing, but instead we've drawn pictures that we call the architectural plans. We have the floor plan, which is equally so an architect's graphical specification for how the home is to be built. And we can certainly trust this, that it's actually dimensioned as you would expect, so that a builder could put the walls in the right place. When the plumber does his work, he'll know that all his work is going to be in the right place, and so forth. First floor, then we're at the second floor. Now we've got the elevations, what are called the elevation views, the front, and in this case, the front and right. Then we have the rear and the left. Then we have our cross sections, and these views help us to understand exactly how the home is going to be built, except it doesn't really tell us how the home is going to be built from the structural perspective. And so what we do now is we're going to look at the structural plans. The first page we see here is somewhat mundane, or may seem mundane, but this is where the devil is in the details, where the engineer is telling us certain standards that this home is to conform to. Look at this. Item 10, all plywood shall be APA performance rated panels conforming to the following requirements. And we're going to have 3/4 inch tongue and groove exposure 1, 3/4 inch span rating 16 inch. So what this is, the engineer is saying that in order for him to stand behind this engineering that he's drawn, the builder is going to be expected to build according to that standard. Well, that's really good, except we need to understand that the language there is great, but we actually need a drawing so that the framer, he'll know where things are going to go. So let's take a look at our the first usable thing that we've got here. Now this home is going to be built on a basement, so this is the basement joists. These are, if you stood in the basement and looked over your head, you're going to see these joists. And he's called these out as 2x12, 16 inches on center, and then he's supporting those with this triple LVL. He's calling it a girt. It's still a beam, but a girt is, what's in a name, right? So he's saying put 3 1 3/4 inch by 9 1/2 inch LVLs. This is laminated veneer lumber. That's like taking a bunch of plywood and or veneers and making some very thick plywood. And in this case, we're going to take 3 LVL beams and we're going to put them together. Typically, these would be glued and spiked together, maybe even bolted together. but this LVLs. And what this does is it creates a kind of a network structurally that supports everything that's going to be above it. What an engineer does, by the way, is his job is to devise a way to transfer all the loads that go all the way from the peak of the roof and transfer those loads to the foundation and then to the soil. So that's really what an engineer is doing by all this engineering. He's doing so in such a way as to eliminate the risk of, obviously, of the thing falling down, but really something over time that can happen where lumber sags. He's going to oversize the lumber to make sure that it doesn't do that. And so this is something that's very important when you're considering building a home. Always budget for structural engineering. Structural engineering to me it's not really an insurance policy, but in a way it does protect both the buyer as well as his builder from liability in the future. And so there's really not a reason not to. It's a legitimate, justifiable job cost to hire a structural engineer to look at both the foundation as well as the frame and to design solutions so that the home, when it's built, will last many, many years to come. So when you're given the option to have engineering or not, really there's no excuse not to. Now, in the event that you're going to build the house for yourself, and the plan maybe comes from an architect, a national architect, maybe you bought it online, very often that architect is going to provide a joist layout, a roof layout, and that layout may even include beams. Just be aware that that may not be fully engineered for your state and for code when that plan was purchased. So be real careful about that. If you're building in a municipality, they will have adopted a code like International Residential Code for a given year. And it's really important that you build according to that. What you would hate to see happen, what I'd hate to see happen for you, is that your framer frames according to the National Architect's design, and lo and behold, a new code is in place. You've got to take a portion of the house apart to make it meet code. That could be really bad. So if you can have a local engineer that's registered in your state that understands the code in the city that you're going to be building in, and then you're going to have the greatest chance to be protected, in my opinion. The main thing is an estimator. What I'm going to do is I'm going to take your architectural plans. I'm going to take whatever joist layout, roof layout, or engineering layouts you provide me, and I'm just going to translate that and create the best takeoff I can based on that information. So I can work with a plan whether you give me engineering or not. I can say categorically that the more accurate information that you give me, the more accurate the estimate's going to be. So that's about all I've got for now. Thank you for taking the time to watch this video. I hope it's been informative for you. And if there's something you'd like to see me do, please let me know in your comments. Please like and share this video. It's important to me that I grow the channel so that other people will know some really good techniques when they come to build their home or if they have questions about estimating. I hope that you'll give me a call if you'd like to. My number's right here. It's 832-277-7203. And of course, you can email me anytime at daniel@residentialestimating.com. I look forward to hearing from you. And once again, thanks, and look forward to seeing you next time.